So for this problem, let's find the limit of the following algebraic function and then use that limit to determine the end behavior of this function. Now, this function is in rational form, but notice our numerator is a polynomial, our denominator is a radical. So we are going to use the technique of simplifying or finding limits of rational functions by dividing every single term in this function by the degree of the denominator. All right, so if we're taking a look at the degree of the denominator, notice our denominator is the square root of 25x to the 6 plus x to the 4th plus x squared. Now, we want the degree of the denominator, so we're going to deal with our leading term here. So if we take a look at the square root of 25x to the 6, well, the square root of this is really 5x cubed. So this is what we're really looking at, with the degree really being x cubed is what this represents. So we are going to find the limit as x approaches a positive infinity, and then we will find the limit as x approaches negative infinity of this. So the limit as x approaches a positive infinity, we are going to divide everything by x cubed. So that's 10x squared divided by x cubed minus 3x squared divided by x cubed plus 8 over x cubed. And the denominator, right? So in the denominator, we can divide it in its radical form, and we can just leave it 25x squared plus x to the 4th plus x squared. And since it's still in its radical, we can go ahead and divide by the x to the 6th and just keep that one normal instead of taking the square root of everything. So that when we simplify this, the limit as x approaches a positive infinity, x cubed cancels with x cubed, making that one a 10, minus 2 of these cancel with 2 of those, making that 3 over x, plus we have 8 over x cubed. In our denominator, this is going to be the square root of x to the 6th over x to the 6th cancels, leaving us with 25, plus 4 of these cancel with 2 of these, so that is 1 over x squared, plus 2 over x to the 6th. Now, rules of fractions here. We know the bigger our denominator is, that fraction is going to go towards 0, right? So if we have x as our denominator, not in the numerator, these are going to go to 0. So this is going to go to 0, this is going to go to 0, this is going to go to 0, and this is going to go to 0. So we're really looking at the limit as x approaches infinity of, well, all we had left in the numerator was the 10. All we had left in the denominator was the square root of 25. And when we simplify that, the square root of 25 is a 5, with the limit being a 2. Notice that the limit is going to be a 2 here, which also does tell us that we do have a horizontal asymptote at y is equal to 2. Now, same process here. Let's find the limit as x approaches negative infinity. Now, if x is going to approach a negative infinity here, since x is approaching a negative infinity, we do need to take that into consideration with this one here. So we are working with the same function. The degree of the numerator, we're going to divide by the same thing. We're going to divide the numerator by x cubed. The denominator, we're going to set it up in that same way here. We are going to have our 10x cubed over x cubed minus 3x squared over x cubed plus 8 over x cubed being divided by that entire denominator, that 25x to the 6th over x to the 6th plus x to the 4th over x to the 6th plus 2 over x to the 6th. Now, here's where we need to take into consideration our negative infinity here, right? Because when we plug in a negative infinity, a negative times a negative times a negative is negative. So even though this x cubed is going to cancel out with this x cubed, this was negative, making this fraction negative. So we actually are going to be left with a negative 10 for that term there. Same thing here, where this number is going to be negative, right? Because a negative times a negative times a negative is negative. So this negative times this negative is going to make our next term positive. Otherwise, that will be a positive 3 over x, since our x's do cancel here. That means this is now going to be a minus 8 over x cubed. Again, just because that x cubed, we are plugging in a negative infinity, which makes that a negative number. Over our denominator, we are dividing by x to the 6th. And since that is an even number, these are not going to be negatives, right? Negative times negative is positive. So as long as it's an even power, these will be positive. So that's just going to break down to the square root of 25 plus 1 over x squared plus 2 over x to the 6th. Same rules as before. All of these fractions with variables in the denominator are going to go to 0, which is going to leave us with a negative 10 in the numerator over the square root of 25, making that negative 10 over 5 or a negative 2. So for this one here, we're going to have a horizontal asymptote at a negative 2. So the limit as x approaches a positive infinity is a positive 2. The limit as x approaches negative infinity is a negative 2. So let's see. We have a positive 2 and a negative 2 for our horizontal asymptotes. So that's going to look something like that, our positive 2 and our negative 2. So we know as x goes positive, it's going to approach this positive 2 here. All right, so the way that that looks is not making an exact graph here, but if you look this graph up, it's going to do something like this, where it's going to approach that 2. On the left-hand side, we know it's approaching negative 2, so our graph is actually going to dip, and it's going to approach that negative 2 just like that. All right, so our end behavior, it's going to shoot off to the left on the right. It's going to shoot off over here on that right-hand side, and they're just going to keep following those lines just like that.